Welcome to Physics Skills, SOH CAH TOA, sine, cosine, tangent, and simple vector addition to do the PS3 assignment. Before you continue, you must make sure your calculator is in degrees. It must be in degrees. Make all your calculations from your given. Do not use an answer that you have calculated. If you made a mistake and use that number, all future values will also be incorrect. Also, if you're using a number that you found and you have rounded it, that may affect the significant figures in the answers that you find after that value. First, we want to find A. The angle I've been given is 30 degrees. This would be the opposite side. And this would be, well, it's the longest side, so that's the hypotenuse. So I've got hypotenuse and opposite. I'm looking at sine, so I'm going to use sine equals opposite over hypotenuse. I want to find the hypotenuse. Hypotenuse has two problems. It's not by itself, and it's also in the denominator. It's on the bottom, and I don't want it to be on the bottom. I want it to be in the numerator or the top. So the first thing I'm going to do is fix the fact that it is in the denominator by multiplying both sides by hypotenuse. Now hypotenuse and hypotenuse will factor out, and I'll rewrite the equation as hypotenuse times sine theta equals opposite. Now again, I want to get hypotenuse by itself, so I'm going to move sine theta. I'm going to do that by dividing both sides by sine theta. So sine theta and sine theta on the left-hand side will factor out. Hypotenuse is now by itself. It's equal to opposite divided by sine theta. So 4.3 divided by sine of 30, and that gives me 8.6. Example B. I'm looking for B. The angle is 30 degrees. That makes this the adjacent side. And I've been given the opposite side, which is 4.3. So the angle, adjacent, opposite, I'm looking at tangent. So tan theta equals opposite over adjacent. I'm looking for the adjacent side. So I need to get adjacent by itself, and I need to, once again, get it off the bottom. So I'll multiply both sides by adjacent to get adjacent off the bottom. Adjacent and adjacent will factor out. Now to get adjacent by itself, I have to get rid of tan theta. So I will divide both sides by tan theta. So tan theta and tan theta will factor out. I now have adjacent isolated, and it's equal to opposite divided by tan theta. So I'll substitute my numbers in, 4.3 divided by tan of 30 degrees. And that gives me 7.448, which then becomes 7.4. In the assignment, it asks you to take all angles and calculations to one decimal place. In this one, I'm looking for C, which is an angle up at the top. I know this is 30 degrees. I know this is 90 degrees, and that all angles in a triangle add up to 180 degrees. So 180 degrees, subtract 30 degrees, subtract 90 degrees, gives me 60. So my answer is 60.0 degrees. Example E. All right, I'm looking for E. This is my angle, so that would make this the opposite side, and I've been given the hypotenuse. So again, I'm using sine. Sine theta equals opposite over hypotenuse. I'm looking for the opposite side, so I need to get opposite by itself. So to get hypotenuse away from opposite, I will multiply both sides by hypotenuse. Hypotenuse and hypotenuse will factor out, leaving opposite by itself. I'll rewrite the formula. Opposite equals hypotenuse multiplied by sine theta. And I can substitute in. So 2.7 multiplied by sine of 43 degrees. And that gives me 1.8. I'm asked to find F now. Again, this is my angle. This is my adjacent side to the angle. and I have the hypotenuse as well, the longest side in the triangle. So if I have adjacent and hypotenuse, I'm using cosine. Cos theta equals adjacent over hypotenuse. So I will substitute in nothing yet because I got to isolate adjacent. So to get adjacent by itself, I'm going to multiply both sides by hypotenuse. So that hypotenuse on the right-hand side will factor out. Now adjacent will be isolated, and it will equal hypotenuse multiplied by cos theta. So adjacent equals 2.7 multiplied by cos of 43. G. Well, that is my hypotenuse, and I've been given the other two sides. So I'm going to be using the formula a squared plus b squared equals c squared, and I'm looking for c squared in this instance because I'm looking for the longest side, which is hypotenuse, which is c. So a squared plus b squared equals c squared. To get c by itself, I will have to square root both sides. So the square root of 4.42 squared plus 3.65 squared gives me 5.73, which gives me a final answer of 5.7. I'm looking for h this time. H is located here, and I've been given the adjacent side, and I've been given the opposite side of 4.42. So I'm going to be using tangent. Tan theta equals opposite over adjacent. I'm looking for the angle, so I need to get tan away from the angle. And if I look on my calculator, the second function of tan is inverse tan. It undoes what tangent does. So I want to take the inverse tan of both sides to get rid of tangent. So tan and tan inverse will factor out, leaving us with just theta. And theta will be equal to the inverse tangent of opposite divided by adjacent. So again, our opposite side is 4.42, that goes on top, and our adjacent is 3.65, so that goes on the bottom. And that gives us a final answer of 50.5 degrees. Part 2, simple vector addition. Scalar. A quantity that does not have direction can simply be added and subtracted from one another. And examples are things like distance, speed, mass, temperature, time, work, and energy. Example, if you walk 2 kilometers and I walked 3 kilometers, we walked a total of 5 kilometers today. Not taking into account direction, we walked a total of 5 kilometers. Vector is a quantity that does have direction. Directions must be taken into account in order for quantities to be added and subtracted from one another. Vector quantities have an arrow placed over their symbol. This signifies that the quantity has a direction associated with it. If the direction associated with the quantity is reversed, the sign associated with the quantity changes. For example, 2.0 meters per second south is equal to negative 2.0 meters per second north. If I'm facing south and walk 2 meters per second, I'll be doing the same speed as I would be doing and the same direction if I look north and walk backwards 2.0 meters per second. Examples of vectors are displacement, velocity, acceleration, force, and momentum. Note that all vectors have an arrow over their symbol. This means that they have a direction, and any time we solve for one of these terms, we need to include the direction with our answer. Consider the following. If you rode a bike 2 kilometers and then I picked that same bike up and rode it 3 kilometers, the bike could be 5 kilometers away from where we started if we both pedaled the same direction. The bike would be 1 kilometer away from its initial starting position if we had ridden the bike in opposite directions. And the bike will be located somewhere between 1 kilometer and 5 kilometers away from where we started if we rode the bike in a direction that was not the same or opposite to one another. Our first example in this section asks us, how fast is something traveling if I'm adding 4 meters per second west to something that's traveling 3 meters per second west? For example, I'm In the Lumsden Creek, I'm paddling my canoe at 4 meters per second west, and the current is pushing me at 3 meters per second west. So to someone standing on the shore, I would appear to be doing 7 meters per second west. Since they're both west, we can add them simply together. Now let's say I am paddling 4 meters per second west, but the current is pushing 3.0 meters per second east. Before I can add these two vectors, I will have to make sure that they are going the same direction. So typically I'll take a look to see which one is winning. And I see west is stronger than east. So I'm going to switch them both to west. So 4.0 meters per second west will remain 4.0 meters per second west. But the east will go from positive 3.0 to negative 3.0. Again, as mentioned just a few seconds ago, when I change the direction from east to west or west to east, the sign will change from either positive to negative or negative to positive. So now I have 4 meters per second west, subtract 3.0 meters per second west, and that's going to give me an answer of 1.0 meters per second west. So if someone was standing on the riverbank and saw me paddling my canoe, I would be traveling up the creek at a speed of 1.0 meters per second west. Again, I'm paddling 4.0 meters per second west, but the current is pushing me back 3.0 meters per second west at the same time. 4.0 meters per second west, subtract 3.0 meters per second east. West is clearly winning here, so again, I'm going to switch them both to west. So this becomes like the first example in this section. 4.0 meters per second west plus 3.0 meters per second west equals 7.0 meters per second west. Uh-oh. Now I can't switch south to west because they run perpendicular to one another. In the event I have two vectors that run perpendicular to one another, I will have to draw them out and then use my math skills to get a value for that overall vector. So this tells me I'm going to go 4.0 meters per second west to start. At the end of that arrow where I'm now located, which is over here, right? I started here. I am now located right here. This is where I'm going to draw my next vector, which takes me 3.0 meters per second south. My starting position is here. My finishing position is here. So I'm going to draw a resultant vector going from start all the way to finish. How am I going to determine what the length of this vector is? Well, I know this side is equal to 4. This side is equal to 3. So I'm going to be using Pythagorean's theorem. So the square root of 4 squared plus 3 squared gives me 5. But this is a vector with direction, so I need to include what the direction of this 5 is, this 5 meters per second. So I drew west first. So I have to measure the angle going from west towards the south. So I want to find this angle using this side, which is my adjacent, which is equal to 4, and my opposite, which is 3. So I'm going to be using tangent. Tan theta equals opposite over adjacent. So inverse tan of 4 over 3 gives me 36.9 degrees. I went west first and then counted 36.9 degrees towards the south. So my answer is written as 5.0 meters per second, west 36.9 degrees south. That means facing west, I then turn 36.9 degrees towards the south, and that will put me facing the direction of this vector. Our last example, 5 meters per second west plus 2 meters per second south plus 1.0 meters per second east, subtract 1.0 meters per second north. Let's start with the west. I have 5.0 meters per second west, and I have 1.0 meters per second east. West is going to win this battle, so I'm going to write them both as west. So 5 0.0 meters per second west will remain 5.0 meters per second west, and the 1.0 meters per second east will become negative 1.0 meters per second west. Between south and north, south is going to win. So I'll leave 2.0 meters per second south as is, but the negative 1.0 meters per second north will be turned to positive 1.0 meters per second south. So 5 meters per second west, subtract 1 meter per second west will give me 4 meters per second west. And 2 meters per second south plus 1 meter per second south will give me 3 meters per second south. And then this turns into the exact same question we had before. So I draw west first, then I go south, draw the resultant vector from start to finish, use Pythagorean's theorem to determine how long the hypotenuse is. I went west first, so I will measure the degrees from a west going towards the south. And we're going to use tangent, so inverse tan of opposite over adjacent will give us theta. And being that it was the same question as the previous example, we got the same answer. But what if? What if someone decided to go and calculate the north-south first before they did the east-west? Well, their answer may look like this. 2 meters per second south is going to remain 2 meters per second south, and we're going to switch the north to south by changing -1 to +1. 2.0 meters per second south plus 1.0 meters per second south. West is going to win, so 5.0 meters per second west will remain 5.0 meters per second west. But the east will also be switched to west. And when the east becomes west, positive 1.0 becomes then negative 1.0 meters per second. So we'll merge the cells. 2.0 meters per second south plus 1.0 meters per second south gives us 3.0 meters per second south. 5.0 meters per second west subtract 1.0 meters per second west gives us 4.0 meters per second west. So when I go to draw this, I'm going to go south first. And then from where I finished, so I started here, I drew 3.0 meters per second south. Now that I'm at this point, I'm going to draw something that goes 4.0 meters per second west. And just like before, I'm going to start at my starting position, and I'm going to draw a resultant vector that travels down to my finishing position. To find its length, we're going to use Pythagorean's theorem again, and we'll get the exact same answer. And just like before, we're going to have to add in a direction. So we started by going south first. So we are going to face south and then measure the number of degrees towards the west we would have to turn to look the direction of this vector. That means that since this is our angle now, 4 is our opposite side, and 3 is our adjacent side. That gives us an answer of 5.0 meters per second, south 53.1 degrees west. So both answers we got are the same. They're both 5.0 meters per second. But if we look west, we would have to turn 36.9 degrees towards the south to look the same direction as the vector. Whereas if I looked south first, I would have to turn 53.1 degrees towards the west to look the same direction as the vector. Get ready for this, special effects. See, it's the same. So that means in the answer key, I typically have two different answers. They both will have the same magnitude, but they'll be two different directions. You are ready to do assignment, you are. A fin, you say?